So, so good morning, good afternoon, and good evening for the participants and presenters from different time zone. Energy and environment are two major concerns in today's world. The use of biomass for the renewable energy production plays an important role in the global agenda of climate change and sustainable development. Bioenergy in form of solid, liquid and gaseous fuel is the largest contributors to the renewable energy portfolio, contributing to about 70% of the total renewable energy sources. For example, in Africa, more than 90% of the total primary energy supply of renewable energy sources is from biomass. As you know, like bamboo is a renewable and a versatile resource. It can be annually harvested without afforestation or degradation. So it is one of the fastest growing plant with high biomass production capacity. With technological development, bamboo can now be converted into various energy sources and products. It can be directly used as a fuel wood, converted into various solid fuels such as charcoal, briquette and pellets, into ethanol, which is a liquid fuel, and also can be converted into gaseous fuel for process heating as well as electricity generation. Energy produced from biomass or from bamboo are advantageous compared to another renewable energy sources such as solar, wind or hydropower, as it is grown by farmer or by communities. It creates employment and income, and it builds like the resilience of the communities. It provides like the benefits to land in form of soil and water, and it enhances the food security of the communities, climate change mitigation and other ecosystem services. The other form of renewable energy such as solar, wind, hydropower, it increases the expenditure. It doesn't provide benefit to land or employment for the people. So energy is a huge market, but will continue to increase. The presentation of this webinar will focus on bamboo energy technologies and triple bottom line benefits which can bring to the communities by showcasing different enterprise models that produce solid fuels, liquid fuels, and electricity. The first presenter of the webinar is Jinwai and Xuan Tao Tao. Jinwai, to introduce Jinwai. Jinwai is INBAR colleague. She is currently working as the capacity building manager with INBAR. She has like over like 20 years of experience in the bamboo sector in the areas of international cooperation, capacity building, rural development and policy making. And Mr. Juan Tauto is currently the director of the Department of Industry Development, Anji Bamboo Academy, China. And Mr. Autao has like over 30 years of experience in bamboo industry development, and he has immensely contributed to a number of development projects in Anji County, including developing high-yielding bamboo forest, strand woven board technology, and bamboo charcoal, barbecue briquettes, and other technologies. As you know, Anji County is one of the foremost and the prominent like in bamboo county in China. Our presentation will throw valuable experiences for us. So I welcome Jinwai and Sean Tao Tao to make their presentation on the bamboo briquettes and like pellet production in China. Floor is yours, Jinwai.
Thank you, Durai. My presentation today is regarding two production units. One is the bamboo briquette charcoal unit, one is the biomass pellet production units, both located in Anji County, Zhejiang Province, China. And the presentation, Mr. Xuan Tao Tao provided me the resources of the data of these two production units. So this presentation is made together with him. Now, the first one is about the bamboo briquette charcoal production unit. First, I would like to introduce the product characteristics. And presently, the product is smoke-free, and if you burn it, you could smell a special kind of fragrance from bamboo material. And it has high calorific value, which is 8,000 kilocalories per kg. And so that's why it can burn for 4 hours and continuous supply high heat. And comparing to wood charcoal, this specific charcoal, because of the uniformity of its quality, means the raw material is uniform. So that means the quality of this charcoal is better. I will explain why, because the main raw materials came from the pre-processing factory of Anji County, and the yellow circled part is the sawdust. That's the main resources. So this part is comes from the yellow part of the bamboo wall, moso bamboo wall, and this is the same age harvested from the managed bamboo forest. So that's why the quality of the charcoal is very high, because the raw material, the quality is uniform. Next, another source of the raw material came from the secondary grade combs harvested from managed moso bamboo forest. So the first grade combs were sent to the pre-processing factories, and then for end product processing. And the secondary ones were sent to like charcoal factory or pulp making factory. So this is the process. And first, we need to make all the raw material uniform in a same granule size. So first we do crushing and smashing, and then we got qualified bamboo powder, and then we further grind them and screen them, because there's some other, like sand, like dirts, mixed with the bamboo, so we need to screen them. And then after that, we do drying. There's a special drying machine, and then shaping. This shaping is kind of extruder. I will show you the picture. So the first picture I'm showing here is the crushing and smashing machine. Now you see there's a garage in the factory that to store the powder, and then this is the drying facility. And after dried, the materials become like this, and they must be immediately put into the shaping machine. And this is the shaping machine. Basically, this technology is developed by Anji County according to their own conditions, and therefore this is a special machine. Of course, now this machine has been used in other provinces, but still managed by Anji people. So you see this charcoal making, briquette charcoal making, is the processing is quite different from the others. So the briquette is made before carbonizing rather than after carbonizing. So after the extruding machine, the briquettes then go to the carbonizer. Anji people, they prefer brick kilns, and this picture showed a chained brick kilns. It's very long. This is a big production. And this kind of chained brick kilns can make sure the uniformity of the heat inside, so you can burn many charcoals at one time at the same pressure and same temperature at the same time. So this saves costs and could make your products of higher quality and be profitable. So you see at the ceiling part, the ceiling is dome-like. there is a hole, and this hole is for the technician to observe the smokes coming out of the kiln, and then to decide, okay, when is the time to open the kiln, and on which stage the carbonizing process has been to. So before you establish the project, you need to have a very experienced technician. And the next step is cooling down. Usually, this picture just to show you it's still burning, but it should be, it's better that the charcoal should be cooling down in the kiln rather than taking out. So this picture is just to draw it out to let you see them. So they need probably several days to cool down in the kiln itself, and you must avoid moisture. And so this is before packaging, and then you select and then pack. And then this goes to the container. So in Anji, each of the briquette charcoal making factory each day can produce 1 container. But it's not like that. So the chained kiln will burn for 2 weeks. So it's just averagely there's 1 container per day, but actually it goes like that. So every 2 weeks. So this is the equipment list. This is only the key equipment. You should have other auxiliary equipments for these products. Like first is the mill to do grinding, crushing, and the screening, and the drying, and the shaping equipment. The carbonization, what I said just now, is the kiln, and some auxiliary product recovery devices. That means to keep the machines running. That's for debugging, this kind of devices. And then byproduct recycling devices means the bamboo vinegar. Bamboo vinegar is distillation of the bamboo charcoal coal tar. When you burn charcoal, there is a kind of coal tar condensed in the chimney, and the kind of oily liquid come out. And then if you distillate it, and then you get a special kind of chemical which is called vinegar, but this is not edible. This is for chemical factories, for daily chemical factories. They could be herbicide or pesticide or fertilizers or cleansing chemicals. And here is a calculation. This data was collected in 2015. So now it's 5 years later, the situation quite different in Anji. Actually, this kind of charcoal factory no longer exists in Anji, and they were moved to west of China. So this is the annual output is 3,000 tons. That means annual production is 3,000 tons of charcoal. And then the raw material portion between raw material to final product is 6:1. So this raw material means fresh bamboo material get to the factory, which is that means 6 tons of raw material can produce 1 ton of charcoal. So that means the annual requirement for raw material is 18,000 tons. It goes to about 60 tons per day. 60 tons per day. Equipment investment. This is only investment for equipment. 2.1 million yuan. So if you calculate it by the exchange rate with US dollar, this will go about 300,000 US dollar. And this does not include the costs for renting the land, for the buildings, and for organizing the production. And for this size of production, you need 40 employees. And so And especially you need 4 charcoal technicians for this size of production. So the total sales revenue and profit. Revenue is 13.2 million yuan, which is about 1.9 million US dollar. And the profit is 1.2 million yuan, which is around 180,000 US dollar. So we calculated according to the factory, the recovery period means that you can claim back the costs in 6 years. So the next production unit, biomass. Biomass pellet, this project we are introducing to you is unique in Anji County because this special technology was not used by other companies in China or in the world. So this belongs to only one company. And this project was developed by the company and together with the support of the government of Anji for 10 years. So let's see the product quality. It's carbon neutral, of course, and it has high calorific value, which is 4,500 kilocalories per kg. And so it could be a very good replacement for coal. And because this kind of fuel can be used for boilers and for power generation. And and note this, there's no additives. If you ask if there's glues or if there's other things for ignition, no, nothing else. This is purely made of bamboo. And there's very low sulfur. If you burn it, it generates very low sulfur and a very low ash content. So it does not well off the furnace or the boiler. So, and also it can have an automatic feeding system. So there's no stoker needed. So it could be the best alternative for coal. It can be used, it can use existing coal furnaces. And you see this processing is quite, this flow is quite simpler than that of charcoal. And so what's not simple is the technology itself. But it's very simple. You can directly use the raw materials, pulverizing it and dry it and form it and then package and then ship out. So this is, you could see that the raw materials requirement is very high. So this factory even doesn't have a place, a space for the raw materials. So they have to be piled out outside of the factory. And you can use the sawdust or use the raw material, the raw comps. And this is, you must first quash them and smash them into particles, and then this is the drying facility. So this is the drying cylinder, and this is also a drying machine. This is the transportation. So after dried and screened, you got this. You got this one, and so this is the core part. This is the pelletizer. So this pelletizer, this is when it's closed, and when it's opened, you could see the core part here. Let's have a closer look. Now our pellet comes from the out of these coals, and this is the final product. And this is how you package them and store them, and then ship out. So the difficult part is to plan and to establish such a factory or to develop such a project. And one of the issues you must consider before establishing such a factory is that you must have sufficient raw material supply. It has to be very sufficient, not only sufficient, but regular. And so this could be a challenge for areas where bamboo industry is not well developed. So this is one key issue before your decision making And the next several things you need to do before setting up such a project is first you need to do with experts an investigation of the local bamboo resources and the local existing processing industry and the market condition. And then we must we prefer that actually if the local area has already a bamboo development plan and which can accommodate this bamboo pelleting factory as part of it, maybe as the primary development part. If not, and then we needed to have a well-elaborated project plan for pelleting machine. And so at initial stage of implementation, we should have a training for the technicians and the management people. And so when the machine is arrived, and we should also have a technical consultancy on the machine. So, and also I suggest that you if you want to transfer this technology and you want to introduce the equipment from China, you'd better choose to have packaged service. That means we will going to help you plan the project and also to help do the training and to ship the machine and to help with the consultancy in the trial production period. And this will make sure that the project will not go detour and all the problems could be resolved. Okay, I think that's all my presentation today. Thank you for your attention. And next, I would like to ask Mr. Xuan Tao to say something about their investigation about the market and the potential for the bamboo biomass pellet product. Thank you. OK， 涛，你可以说了。
怎么说就？
然后你就说两句，就是关于这个竹颗粒这个产品它的前景，市场发展前景，以及它的这个好处吧。
Good morning, everyone. Good afternoon and good evening. Thanks for Chairman Zhu Lei, and thanks for Ms. Jing Wei and Ms. Liu. Thanks for everyone. Let me introduce about bamboo biomass pellets to you. I think it is very simple. Bamboo pellets replace the coal. It is very simple. So our consumed coal too much. So we develop bamboo pellets to replace the coal. I think the market is very big. Now the boiler. Do you know the boiler? To fuel. The fuel is coal. We change the boiler very easy to use the bamboo pellets. The technology is very successful. And now many machines would be developed, and in the maybe Europe and USA in the winter, very cool. Now the fireplace very developed now. In the Europe and now China, we use the fireplace now. But the fireplace, the pellets is 6 millimeter diameter, 6 millimeter. the electricity fire plant replaces the core. The diameter is 8 millimeter. Different, very different. And another machine is invented. Do you know cooking? Cooking in the restaurant, cooking machine use the pellet. We have had a test. The fire is blue, and the fire shoot out maybe 6 meters, very strong. The blue fire shoot out this machine. And another machine is a heater machine. I think we heat the tea and the coffee more better. If we use the coal to heat the tea and the coffee, you smell uncomfortable. So our bamboo pellets make a heater to dry the tea and dry the coffee is better. Another, I think our bamboo forest is very rich, very rich. Maybe only China, maybe India and Indonesia and not many countries developed and not cut many bamboo. Many bamboo lot away in the mountain. So our pellets project, we consume very big bamboo resources. Bamboo village in the villages in the bamboo forest, they can cut the bamboo and sell their bamboo, and they get money, and they have income, I think. So I think the bamboo pellets is a good project to bamboo forest area, and good to the bamboo forest people. Another, I know only Anji bamboo forest has several hundred years, almost 1,000, maybe 2,000 years management. It is we cut the bamboo is very easy, but many bamboo forest is nature. We should improve it. So maybe improve it. Cost is high. First, we cut the bamboo. We could make the bamboo pellets and save the cost to develop a nature bamboo forest. I think it is a good project. Another, now in China, bamboo pulp project is very successful. I have been to Ethiopia. Maybe I had contacted Mr. Julie before. I know Ethiopia bamboo is good to make the bamboo pulp, but it's the nature. Many bamboo is very too old. So we could cut the bamboo and improve the bamboo. Bamboo pulp need 2 years old and 3 years old bamboo. So the first stage, the first step, we should improve the natural bamboo forest. Now, so we cut the bamboo, we can make the bamboo pellets to reduce the cost of new bamboo forest to establish, to set up, I think. So the third question, I think, if one bamboo area, they should develop a bamboo pellets. We should maybe many factors we should investigate. Yeah, and the bamboo material price, labor cost, local electricity price, and the traffic. It is better maybe railway. I think railway is very important. Railway, and then near the port. Yeah. I think I only yeah.
Okay, great.
Sorry,
Yeah.
I talk only just a bit.
Yeah, yeah. Thank you very much, Sean Kauto and like some Jinwai. So it is important from your presentation, we understand that the bamboo pellet has a huge market and it has huge potential in our countries, plus it has the huge potential in US and Europe as well. And the unmanaged bamboo forests in huge quantities, like be it in India, be it in Africa, be it in other continents, can be transformed by value adding it like some first into pellets and like some charcoal and like some simple product, and then like some move into the high end value chain. So yeah, thank you very much, Jinwai and Professor Shwant Hatov. Now, Dr. Bharati is like one of the prominent person in like the bamboo sector in India. He is an agriculture scientist with like over 30 years of experience in plant propagation by tissue culture. And for the past like 15 years, since we met during the World Bamboo Congress in 2004, he has been like working in like some bamboo research for producing high yielding clones and into standardized agronomical practices for producing bamboo. And he is also the founder director of Growmore like Biotech Limited, like which is one of the biggest tissue culture unit producing tropical bamboo plants in the world. And it has the capacity to produce around like 1 million plants per like a month or so. So Dr. Bharati's presentation is to showcase different emerging technologies of like bamboo, ethanol, gaseous fuels, and so on. So now the floor is yours, Dr. Bharati. Unmute, sir.
Thank you, Dr. Dilrai. Thank you very much. Good evening to all of you. And this is Dr. Bharati, and let me present my presentation. Yeah, I'll be talking on the bamboo as a captive energy plantation for the production of ethanol, bio-CNG, coal substitution, and liquid fuel through IH2 technology. And this are all renewable resources can reduce the global warming in a great way. Now, I'll be talking on the three topics. One is how the bamboo is suitable for the bioenergy. Then the next is going to be what are the different energy products being trialed and validated now. And the third is going to be what are the constraints and what are the opportunities available. And let's take it look at how it's suitable. Bamboo burns very well. But normally bamboo is used as a high value product. Today, bamboo, when it is used, a product which is sold at $1,500 per ton, whereas somebody wants to make energy, it should be only $60. So the value of the bamboo should be low enough to convert into energy. You cannot just only rely only on the waste material, but the bamboo is burnable. It has got excellent amount of carbon content. They have 48 to 52% is the carbon which is sequestered from the atmosphere. And over and above that, it has got a fermentable sugar, 65% fermentable sugar of cellulose and hemicellulose, and that's what is able to get converted into ethanol or a bio-CNG gas. Then it does have an energy value as such without doing anything. It has got 4,000 kilocalorie. And what is very interesting is 1% ash content in that. Normally, when you look at the coal, they vary from 10%, 15%, 20%, goes up to 30%. And this is the one which has got the least amount of this thing. So the bamboo grows so fast. You look at them, they are growing at a speed of 1.5 feet a day. I just put a clock in the background. It's going, and it started from here. Now, it is grown. It is the daytime now. It's coming, and the growth is 3 o'clock now. Evening 6 o'clock, 24 hours. It is. That is a fastest growing plant, but we have not really utilized for these kind of a purpose. But if you look at the bamboo, the bamboo, when you say energy crop, there are many crops available. Switchgrass is there, jane grass is there, poplar is there, eucalyptus is there, and quite a few things are there, and the willow. But all are giving a lesser yield as compared to bamboo. Bamboo is able to go up to 26.5 tons recorded in Taiwan, US, and China. But we have been working, I've been working for the last 15 years to see that this converted into an energy crop, and where we could push it from 40 ton to 65 tons, though the potential is 100 tons per acre, but then the practically we are able to go up to 65 tons now. What has happened in India, I could see a case history where it was only 800,000 rupees a ton around 8 years back, the cost of the biomass. Everybody went for the energy through the bamboo biomass, then went up to 2,500, 3,500, now it's relying at 4,500 rupees. But at this cost, we cannot make energy out of the bamboo. So what we did, we made it deliver the technology by which we can do this and reduce the cost to 1,500 rupees a ton. And that's the place where the bamboos come into picture. Bamboo, when you do it as a captive energy plantation, every factory, if they're going to grow on their own, that cost is only 1,500 rupees. It's hardly around $25 per ton. And the bamboo, when you look at this, their moisture content is 12 to 15% when it is dry. Ash content is only 0.4 to 1%. Volatile matter is excellent for burning, and the fixed carbon is low. The sulfur is least, and the carbon is the calorific value is 4,500 calories. Then the bamboo has got several advantages of fuel: high calorie value, low ash content, continuously can harvest it. Once planted, it can grow for several hundred years. If the bamboo be sterile bamboo, there are species like Bambusa bulkova, Bambusa vulgaris, and they are sterile, and they can be continuously grown without replanting. And plant once in 100 years, so it can keep on growing forever. All other energy crop need to be replaced at a particular time. And bamboo is a grass, because of which the tar content is very low, which is one of the interference in most of the boiler. In case the power is going to be very excess, it could be converted into so many alternative products. It is not that only energy should be done with this. And the cost, what is very attractive is when you do that, it's only $25 to $23 to $25, the least. And this is what is going to bring in a lot of impact into this. Let's see, like, what are the energy products being trialed out and validated now. Bamboo as an energy plantation, when you grow them, and it is mainly for switching over from the fossil fuel to the renewable energy. The first is coal got replaced. 1 ton of coal or 4,000 kilocalorie getting replaced with the bamboo. The cement industry is doing it. The iron ore industry is doing it. All these people have now started working on it. The bio-CNG gas, 4 kilos of bamboo is able to get converted into 1 kilogram of CNG gas, which is a beautiful product for the vehicle to run. Similarly, biofuel, the oil, or through the IoT technology, today we are able to convert them into petrol or diesel or jet fuel. And 4 kilos of bamboo is going to produce 1 liter petrol or diesel. And electricity, every kilogram bamboo is producing electricity. And similarly, bioethanol, the cellulose, I said 65% cellulose, when it is getting digested, it's able to get converted into ethanol. Again, 4 kilos of bamboo is able to get converted into 1 liter ethanol. That is the way the bamboo is able to get converted. Bamboo is like this, then it's able to produce electricity. I said 1 kilogram is able to produce 1 kilowatt, which means 200 acres, 80 hectares going to produce 1 megawatt. One of our panelists is going to talk more onto this, and the cost is going to be least $0.04 per kilowatt hour. And let me look at the ethanol. Ethanol is another beautiful, wonderful product because bamboo has got a huge quantity of lignocellulosic material, and the cellulose content is excellent, and that is renewable, and it's able to get converted. As I said, it has got 65% is the cellulose content, only 19% is the lignin, which is non-digestible. And the process is simple. Initially, it has to be shredded and the chemical treatment done, then the enzymatic action is done, used for breaking down. The further it is by fermentation, it is converted within a week time bamboo into ethanol. Now, look at this, 4 kg of bamboo is able to make 1.2 liter, 1 kilogram ethanol or 1.2 liter ethanol. Look at the 1 acre of bamboo is able to produce 10,000 liter ethanol, extremely high. A cultivated bamboo can do that. And today we have sugarcane as a choice for ethanol, which is able to produce 40 tons of sugarcane get converted into ethanol from the molasses. The US and other countries where the sugarcane cannot be grown, starch is there through the cob, maize, and that is converted into sugar into ethanol. Bamboo does not have sugar, does not have starch, but it's got a lot of cellulose, which is first pre-treatment converted into starch into sugar into ethanol. I mean, this is science. Industry wants to do it. They want to see what is the efficiency. Now, efficiency operation, you look at the sugarcane is able to give 500 liter from 40 ton of sugarcane. Even if you convert the entire juice, you'll be able to make only 2,000 liter per acre per year. Maize, 3 crops, 3,000 liter, better than sugarcane. But it is food versus fuel. But bamboo can give you 10,000 liter per acre, for which you don't need to replant them at all. Sugarcane has to be replanted every 1 or 2 years, whereas maize has to be replanted 3 times a year. Bamboo plant once, you can keep on harvesting and do that. And India, with our president, we went to Finland and got the technology, and Bharat Petroleum in India is coming up with a plant to produce 60,000 liter. Today it's upgraded to 1,000 liter per day, and that process is going on now. That's not the end of the story. Like, you have bamboo could be converted into syngas, which is a simple thing. And from the syngas, it is converted into oil, bamboo wood oil. And this oil, when you do that, you have byproduct of charcoal. The charcoal is able to give back the money for whatever the raw material you want to use bamboo, oil becomes free. This is the process by which you are getting 20% oil, 20% biochar, and the 20% is the non-condensable gas still could be used for heating. Then this is done by many institutions. One of the institutions in Gujarat in India is doing this work. Now, taking this forward, wood to oil conversion is much more sophisticated now. A technology called IH technology has come into the picture, where bamboo biomass is taken through hydropyrolysis. It's been converted into biochar and a gas. The gas is further reacted through a reactor, which is able to convert gasoline, jet fuel, diesel, and what emission comes out is converted into hydrogen, again used for hydrogenization here. And this particular technology patented, developed by Shell. It's going to go in a very big way. Now, all these are potential technology available for bamboo to be explored if the bamboo can be grown as an energy crop. Now, CNG gas. There is the company called Agrogas in Pune has developed this technology. You don't need to wait for a week like in ethanol. The bamboo is taken in the reactor, it is placed for 1 day, 24 hours, digested, and it's getting converted into gas. That gas is filtered for carbon dioxide, carbon monoxide, sulfur dioxide, and it is put in the cylinder, the methane. In the front of this, they have the bunk. The bunk is supplying the gas to the auto rickshaws, to the car, to the bus vehicles. And it's going on for the last 2 years. They can use any agriculture product, including bamboo. That's the best part of the bamboo to be done. And when you're using it 24 hours to do that, 4 kg bamboo makes 1 kg gas, and 300 acre or maximum 350 acre needed to make 5,000 kg gas. A bunk on the highway, national highway, can give you continuously gas. And this is one of the breakthrough technology. But let's not go to very high tech. Just replace cement industries, coal. The coal today we are able to show people that the bamboo can do that. Dalmia's in India has started doing it, and Ultratech is going on with the 50 different factories in India. And what happens is the carbon footprint is very high for the cement. The international is 612 kgs of global footprint. Indian average is 579. The Dalmia group is only 493. But now they have units in Northeast where full of bamboos are there. All the waste have been used, and there they could reduce to 330, 50% of the globe average. They don't stop with this. They are working towards now zero carbon emission. They're going to achieve in another 10 years time, for which the work is started now. Bamboo is going to be the main commodity to do this. They're going to cultivate the bamboo as an energy crop. So to replace the coal, if you look at it, bamboo could replace coal directly or could convert into coal, or you can torrefy the bamboo. Torrefied bamboo has got higher energy, it's brittle and can be mixed along with the coal very easily. Now, I looked at the market. What is the market? The market is 820 million tons of coal being used in India. In this coal, 200 million tons every year we are importing it, 200 million tons. which can replace by 200 million tons of bamboo. Everyone used to ask me, where is the market for bamboo? Now look at this market. Now, if you have 200 million ton, if you're cultivating beautifully, wonderfully, then it can give you a 5 million acre of plantations needed. Today, sugarcane is cultivated as a cash crop only in 5 million hectare, but the bamboo only for coal replacement, only for replacing the imported coal, you need much more than that. Now, you might ask, what is the market is there available? So total bamboo requirement, we just calculated 136 million ton for if you want to do the bio-CNG for India, and 908 million ton if you want to replace the coal in India, and electricity 350 million tons, 804 million tons for the biofuel, and 190 million ton for the bioethanol. All put together, almost 2,400 million tons, and that's amounts to 60 million acre. Let's say another 20 years time you're going to achieve this. Believe me, this is an area today. Sugarcane is there somewhere around 14 million acres, and this is 5 times more than that. That is the demand, and that's going to be the crop of future. Bamboo is going to be crop of future. So believe me, bamboo is the next disruptive technology to dominate the future for energy sector. Huge quantity you need, and nobody can satisfy the requirement. We never believed when cell phone came into picture. Now, what are the constraints and opportunities available to do this? One is bamboo today is grown like this. In the forest, 0.5 million ton, whereas if you're 0.5 tons per acre, whereas when a farmer is growing, he's able to get 4 to 8 tons per acre. But this is not the broiler way of growing chicken. Chicken, if it is grown, like in a bamboo could be a broiler bamboo, when you grow them in a precision farming, then it will be able to produce 40 tons per acre. And this is what Jersey cow, this is not the wild cow. And to do that as an energy plantation, today what we have, our bamboos are planted like this. No, this is good for construction. This is good for furniture making. This is good for making many of the product. But for energy, it should be a close planting and continuous planting and a row planting. Let's see that. Now to get this 40 ton is a big number. It's a big number. To get it, you choose the best bamboo species. There are many bamboo species. There are some of the species like Bambusa balkova, Bambusa newtons. They are high biomass, high energy. They grow fast. That's the best one. Among them, there are a lot of clones are there. I've been working in the clone development, and I developed one clone by name Bhima Bamboo, which is doing wonderfully very well for the energy. It can be done for construction as well as for this. But how do you get the good planting material? By seeds. You have got a lot of variation. By cutting, you carry forward some of the diseases, and the vigor is not there. Tissue culture is the best method, which I developed, as Dr. Durai said. Been working for 40 years in tissue culture. I've been working in tissue culture of bamboo for the last 20 years. The last 15 years, I've been commercially producing plants, and these are all producing large quantity. As he says, it's around 100,000 plants every day is manufactured, produced. It's no more research. Planting. How do you plant them? It's a planting when you do that 8 feet, 12 feet, 8 feet, 12 feet rows, and the plants are going to be planted every 4 feet, continuous. After that, it's going to be a wall of bamboo. It's not going to be a tree of bamboo. And 1,000 plants per acre, harvest start after 2.5 years, 50 tons per acre, 40 to 50 tons per acre is the aim. Let's see, this is the way it's planted. No more pit planting. We are used to planting in a pits. Now, if you want to grow the bamboo in a row, it has to be planted in a continuous trench. All these I've been spending my 15 years of research and developing this method where the pits are made, manure is put inside, the topsoil is covered, and the planting is done in that. So best agronomy is needed to do that, and the right amount of irrigation and the nutrients should be applied to the fertigation system. Let's see that how it's done. First day of the plant getting planted. And in 2 months' time, they all put in a line. It's not a very high rainfall area, 600 millimeters rainfall, but the drip line is able to feed them with 5 liters per day, starting with here. And then you see them, they have 4 months' time, shoots up the growth. And the 12 feet gap is slowly getting reduced. Another 4 months from now, it's 8 months. The bamboo, the 12 feet is reduced to 2 feet now. The leaves have become bigger. It has went and touched the manure. It's able to make a compound wall of bamboo. And another 4 months, 12 months that is, completely covered. No sunlight is wasted. It's a green solar panel completely covered. The whole 4,000 square meter, 1 acre is covered, and they are able to really do the photosynthesis. Right? The plant is ready for harvest in 2.5 years' time. And it's harvested manually, or it could be mechanically harvested. And all the plants have got solid biomass. And this solid biomass is able to, either clear cut harvest, completely cut, then you can cut again after 2 years. You see them, many people think that it cannot be cut like this. We have done so much amount of work now, it's possible. You see them in 2 weeks time, it's coming back. Another 4 weeks from now, it's shooting up so much. Another 6 weeks, totally it is ready. So all the cut branches are there, leaves are there, still started growing. Bamboos like a cockroach. They can come very well anywhere. Give them a little bit of input, they're going to be the extremely powerful crop. This is how the plant tree looks like in 2 years' time, again ready for clear-cut harvesting. And the bamboo should be grown as a line crop, like a sugar cane. Sugar cane is an energy crop. Bamboo should be an energy crop. Growing like that is very important. Then it becomes an energy plantation. And this is a beautiful energy plantation, which is going to be the disruptive technology to dominate the future. And thanks for listening to me for such a long time. Thank you, Dr. Durai, and every one of you for giving me this opportunity. I hope let's take the bamboo to the next level. Thank you.
Okay, thank you, Bharati, for your inspiring and live energy presentation. So now the another presenter is Mr. Jaya Wahanu. He is the founder and CEO of Clean Power Indonesia, an Indonesian company that specializes in the development of the community-based energy forest. And I are focusing like mainly on bamboo, and then utilize it in form of like biomass gasification technology to produce electricity and its co-product. He has extensive experience in energy sector, including bamboo, like forestry, and then waste to energy and so on. The Clean Power Indonesia is also the recipient of Frost and Sullivan Indonesian Excellent Award, Sankalp Forum Award, and Sustainable Business Award in recognition of their effort in the renewable energy sector for the rural electrification development in Indonesia. Now I invite Mr. Jaya Wahanu to make the presentation. The floor is yours, sir.
Thank you, Durai. Good afternoon and good evening, everybody. I would like to upload my presentation first. So I will present the community-based bamboo biomass distributed power as a way to increase rural electrification in Indonesia. As you know, Indonesia consists of tens of thousands of islands. The official number is 17,000 something islands all over Indonesia. Not all of them inhabited. Around 9,000 islands are inhabited. And we started in one island called Mentawai in West Sumatra. As you can see, Indonesia, in some of the part of Indonesia is still dark, which is not because they don't have people, but that's because of the electricity access is very limited. So what happens when people living there and have no access to reliable and equitable electricity? It means that they cannot develop. UN put them standard of a good life threshold is around 4,000 kilowatt hour per capita per year. Indonesia is around 1,000. That's national average. In the big city, of course, is much higher, like 4,000 in Jakarta. But in rural communities all over Indonesia, it's probably around 200, 300 kilowatt hour per capita per year. So it's very low in terms of consumption of electricity. And Mentawai itself, it's actually famous all over the world. There's late Paul Walker came frequently to serve, and also Chris Hemsworth, another Hollywood star, he plays in the Avengers, I believe, and they come. All these surfers around the world came to Mentawai and every year because of the surfing, which is they have the longest surfing season, and they have many surfing spots, so to speak. So this is a very famous area, but unfortunately, many of the people still live in the dark. So what happened when they don't have access to grid electricity? Not only that they couldn't develop their community, if they have electricity, it will be very expensive. They pay around 10 to 20 times higher than the people living in the big city like in Jakarta or other cities all over Indonesia and the big islands. So this happened in many communities, especially in the small islands like Mentawai. Some receive solar PV. That's a grant assistance from central government, but they couldn't maintain it properly. So within 2-3 years, they go back to dark because they don't have money to replace and maintain the system. So what we propose is that the community keep planting the bamboo, and we also give them more seedlings for them to plant, and they use it for jobs creation. So all the households are participating, and they become the producer or the biomass. They supply to the power plant, and the power plant give back the electricity to the community, and they use the electricity as means of development. So there are three parties working together in this scheme. One is the community, that's number one. Number two is the power producer, which is Clean Power Indonesia and partners. And number three is the PLN, which is the state-owned utility company in Indonesia. And they have monopoly all over the country. So they are the only company in Indonesia that can distribute power to the community. And they become our off-taker. Because it's a state-owned, then the project is bankable because it's a long-term contract backed up by the government. And because the government comes in as the distributor of electricity, they can distribute in subsidized tariff. So the community pays very low tariff, around 3 cents per kilowatt hour. And community sell the bamboo to the power plant. In that case, the community will pay the electricity bill from the proceeds that they got from selling the bamboo. In this loop, they got electricity almost for free because they don't need to pay out of the pocket. So it's not only that the bamboo can produce electricity or power to the community, but also the byproduct they use for cooking fuel to replace the propane or LPG. Or even the firewood. So they have smokeless fuel for cooking, which is much more healthier for them. And also the excess heat, we can use it for drying the crop. So it's not only that help the community to have reliable power, but also cooking fuel, reliable supply of cooking fuel, and reliable supply of heat for crop drying. So typically this is the arrangement. The community plant the bamboo surrounding their village. So it's if you see the all the green dots there, that represent the bamboo land allocation for each household, and they use this for supplying the bamboo. Which is 1.5, right now it's 150 kilowatt, but in the future they can increase it to 1.5 megawatt because of the bamboo that already planted there. Here's the thing in Indonesia, the challenge of bringing electricity to remote villages, it's enormous. In this particular case, we have to mobilize the equipment with helicopters, even though that is only a small capacity because there is no road going into this village and access through the river is not really reliable. But because this is funded by the grant from the US government, this is not a case that can be copied as a commercial, but this is a proof of concept saying that the community, the business and the state can work together and bring reliable and equitable electricity. The next project that we are doing in the eastern part of Indonesia is solely a commercial project with the project financing. I will talk about that later on in the slide. So this is the typical system configuration from 50 kilowatt up to 1 megawatt. It is a self-contained system. It has no water scrubber. It's dry filter system. So there is no wastewater discharge because we put this in a very sensitive habitat in Siberut Island, which is also natural conservation area. It's called Biosphere Reserve, recognized by UNESCO since 1990. So we put this in a very sensitive habitat. One particular power plant is next to the mangrove, so we cannot pollute the area. We cannot discharge wastewater into the area. So this is the good system that can put in a very sensitive habitat. Doesn't pollute the water, doesn't pollute the air surrounding the power plant. So how we bring the operators? We train the locals. So we have the locals recruited, and we train them for more than a year, and now they become operators for the power plant. We have 3 of these power plants, such of this in Mentawai already, and we plan to replicate to other 5 more locations in the same island. And in the other island, in eastern part of Indonesia, we are starting with the 10 locations. So this is distributed power plant. The advantage of having distributed power plant is to have the logistic much easier to handle. So typically 500 kilowatt system to 2.5 megawatt system will require around 5 kilometer to 10 kilometer radius of bamboo supply. And feedstock are exclusively supplied by locals. There are no biomass supplied from other communities or even from other islands. So this is going to be a self-reliance community. They have the source of energy within their village. They have the power plant within the village, and the jobs are created for the local population as well. The good thing about having the bamboo planted surrounding the village for primary source of energy, this is good tools to empower women and indigenous people. So because of the bamboo doesn't require special tools, so women can work without leaving their home, and they cut the bamboo, they chip the bamboo, and they even transport the bamboo by feet, and they get the money and they pay for electricity from that. So this is the power plant, the first power plant that has been light up since April 2018. I believe this is the first community-based bamboo biomass power plant in the world because it has the bamboo forest surrounding them. and the power plant is supplying the electricity back to the community. It's a isolated grid. It's a whole community participate. We're quite proud that we claim the title to be the first community-based bamboo biomass power plant in the world, but we certainly don't want to sit on our laurel. We want to replicate this all over Indonesia. And since then, the people of Salikuma village, that's the name of the village, had access of reliable and equitable, affordable, and sustainable electricity for years to come. The government adopt this as a best practice, and the Minister of National Development Planning inaugurated this power plant back in September 17, 2019. So this is a good example on how the central government, regional government, the businesses and the PLN as the state utility company work together to achieve electrification in the rural area. The project that we have in Mentawai is also showcased in the publication by Alliance for Rural Electrification back in October last year, and it's called Private Sector Driven Business Model for Clean Energy Mini-Grids. Interestingly, the biomass distributed power that we established in Mentawai has the highest jobs created compared to solar PV and hydro, obviously. And also the annual greenhouse gas emission reduction is the highest. It's much higher because solar PV with similar capacity only around tens of tons per year, with biomass power plant, especially from bamboo, can reach like 3,000 tons of CO2 equivalent per year, which is quite high for less than 1 megawatt capacity of biomass power plant. And this is also according to INBAR study back in 2018, when we reforest the area and use it for energy, this system will sequester more carbon in the long run. So this is going to be a very powerful solution for Indonesia, as Indonesia has a large area that is deforested and degraded, and we just received the payment from Norway as a REDD plus payment, and Norway committed $1 billion for Indonesia to restore the degraded and deforested area. So this is an opportunity to be a RED plus project in the future. And obviously, with the reliable power, the community can develop not only for lighting, but also for coconut sugar production, rural fish processing facility. This opportunity is enormous. It's unlimited. And the community can grow the economy, especially in the pandemic era that we need the community to rely on themselves. And this is the way to do it. PLN, as the state-owned utility company, also likes the idea, obviously, because they save money. They save, in this particular case that we developed some simulation based on 2.2 megawatt, they will save a lot of money, like 14 billion rupiah per year. That's probably around 1 million. 1 million to 1.5 million dollar per year, and the country also save money for subsidy, and because of 70% of our diesel fuel are imported, then we also save some foreign currency by switching from diesel fuel generated power to the biomass. And the plus side, the community is now becoming more active with this program. With diesel or hybrid diesel and solar PV, they're not part of the solution. They're just the passive receiver of the power plant. But with the biomass, they are more active participant and they receive money from selling the biomass. So what is the potential? I mentioned in the beginning of the presentation that we have 9,000 islands that represent around 50,000 villages all over the country that still do not have reliable and equitable access of electricity. 50,000. That's a lot of villages need to be electrified. Not only that, we also alleviate poverty because now with the electricity that is available 24/7, they can develop their community much better. And the 20 million hectares of degraded and marginalized land all over Indonesia need to be restored, and that can be a carbon sequestration as well. Finally, we also want to rely on the renewable energy, and we have allowed about 5,000 to 10,000 megawatts of diesel genset that can be replaced by this system. So this is the impact is not only for the energy transition, but also for poverty alleviation and carbon sequestration, all in one project. Where the money coming from? So this is the platform, we call it a blended financing platform that is already created by the government of Indonesia since October 2018. It's called SDG Indonesia 1. SDG is stand for Sustainable Development Goal. The money that is already collected by the government from various sources like ADB, AIB, KfW, World Bank, AFD, and other organization is around $3 billion US. That's available to finance a project like this because SDG not only about providing clean energy, but also for poverty alleviation and protect the land and protect water and so on and so forth. So the money is available. The government adopt this as a best practice. Now it's the time to replicate. And this is the last slide. What I want to reiterate here, countries all over the world now we're worried about the recession, economic recession because of the COVID-19. Countries all over the world, especially Indonesia, developing countries like Indonesia, need to create jobs urgently. We cannot wait for 1 year, 2 years. We have to create jobs right away. Planting the bamboo and switching from diesel gensets to biomass create jobs instantly, not only in the big island, but also in a small island in the remote areas, all over Indonesia. So this is the way to create jobs very fast. Second, that the PLN as the state utility company need to reduce costs because government has a very limited funding now. So they have to reduce costs, and this is the way to reduce costs by having distributed power generation, getting the primary energy from local. Number three, we need to be self-sufficient in terms of energy, not only in the big islands, but in the small island. Many communities now have to rely on themselves, not only about they have to produce their own energy, but they have to produce their own food. So this is the way to increase the self-reliance on energy and food all over Indonesia. That can be replicated all over ASEAN, that can be replicated all over Asia Pacific, can be replicated all over Africa. And I believe the bamboo biomass will be key to achieve all those targets, and because we have a commitment as well By 2025, we have to reach 23% of renewable energy. This will contribute to that as well. Thank you, Durai. Go back to you.
Okay, thank you, Jaya, for your great presentation. I think your presentation and your model have shown that the farmers, they don't only produce food, the farmers can also produce like some energy. So the farmers can capture the market of the food, like some market also, as well as the energy market as well. So it is great presentation, and then we would like to see the same model being like replicated in small island states and as well as in countries where they don't have access to electricity, and it can provide employment to the communities, to the farmers, and it also will benefit the environment on a huge scale. So it is an interesting case study. So our next presenter is Dr. Paul Osai Hotu. He is currently a lecturer in Famekuma University of Science and Technology, Ghana. He was also our former INBAR colleague. He worked as the West Africa Regional Coordinator earlier. He is a bamboo enthusiast and an ambassador who is interested to seeing Ghana and Africa tap into the many green economic benefits which the bamboo can offer. His presentation is specifically on a small enterprise model producing the bamboo charcoal and its products. The floor is yours, Dr. Paul.
Thank you very much, Durai, and hello everybody. I am happy to have this opportunity to share with you some experiences from Ghana in our attempts to substitute bamboo as a feedstock for charcoal production. I will start with some background. Yes, I have it now. So biomass, as has been mentioned by the earlier speakers, is a major source of energy in the developing world. In Africa, an estimated 80% of the population rely on biomass energy for domestic and industrial use. And by biomass energy, I mean traditional firewood, but also charcoal. In Ghana, over the years, we are seeing some transition from the use of biomass energy to the use of liquefied petroleum gas, particularly in the urban areas. But even then, still in the urban areas, charcoal remains a very important source of energy for domestic use. In the villages, firewood is the dominant source of energy, in most places accounting for 100% of the energy used in the homes. In Ghana, it is estimated that we remove over 30 million cubic meters of wood annually for the purpose of biomass energy. And this is significant because it constitutes as high as 85% of the total wood removal in Ghana. And again, most of the wood we use for biomass energy in Ghana is not planted. It comes from the natural forest, fallow lands, and the savanna woodlands. So obviously, the use of biomass energy is often cited as one of the major causes of environmental degradation in Ghana. Nevertheless, this high use of biomass energy in Ghana and the rest of Africa can't be expected to remain same into the foreseeable future. So there is an urgent need to find alternative and more sustainable sources of feedstock for biomass energy. And this is where bamboo comes in. Bamboo is attracting attention globally as feedstock for biomass energy. It grows fast, as has been mentioned already, able to grow up to 1 meter in a single day. It is renewable and it is abundant in many tropical countries where it grows naturally, and where many of these countries do not have commercial use for the bamboo as yet. When a bamboo plantation is established, harvesting can start 3 to 6 years. And this is remarkable. Comparing that to the closest competitor in Africa is probably acacia, which takes about 5 to 7 years to be ready for harvesting. A new shoot, once the stand is established, the new shoot can grow to their full size in a single year, only becoming harder in the subsequent years. As Dr. Barati mentioned, bamboo has rhizome, being a grass, and as the plantation ages, the rhizome spreads, and as it spreads, it develops new shoots. In fact, you may have come across an accusation that bamboo is invasive because of the spreading rhizomes. But for the purpose of biomass energy, this is a useful feature because it means exponential increase in the number of shoots as the plantation ages. And if you harvest bamboo, you don't need to plant because of the rhizomes. New shoots develop every year from the underground rhizomes. When you put all these features together, bamboo becomes an extremely renewable source of feedstock for biomass energy. In Ghana, it is estimated that we could actually substitute bamboo for about 70% of the conventional wood we use for charcoal production. And this is significant because charcoal is quite a big industry in Ghana. And if we could substitute bamboo for 70% of the wood we use for charcoal, that would save the country substantial forest degradation. Now let's talk about bamboo charcoal. In fact, the practice of producing charcoal from bamboo is not new. China has a very long history and presently produces several thousand tons of bamboo charcoal every year. Bamboo charcoal compares quite favorably with charcoal made from conventional wood. Yield rates of between 20 to 30% have been recorded for bamboo charcoal, which is comparable to acacia. The calorific value is also comparable to acacia. And I keep comparing to acacia because in Ghana and many African countries, acacia has become one of the main species being planted for the purpose of biomass energy. In comparison to conventional wood charcoal, bamboo charcoal is known to have higher absorption capacity, which makes it preferable if you want to use the charcoal for the purpose as a cleaning agent for purification. A study published by Pate et al. In 2017 indicated that actually it is greener to produce charcoal from bamboo than to produce charcoal from acacia and teak. INBAR introduced the technology for producing charcoal from bamboo into Ghana through a project which was implemented in Ghana and Ethiopia between 2009 and then 2013. And since the technology was introduced into Ghana, some private sector actors have taken up the technology and are producing bamboo charcoal. But at the moment, we are yet to have wide-scale adoption of the technology. So it's important to understand what has been done so far in Ghana and what needs to be done to achieve a wider application of the bamboo charcoal technology in Ghana. So I'm going to briefly share some 3 cases of bamboo charcoal production in Ghana. The first case I share is that of Ancobra Farms Limited, which is a branch of a beach resort in Ghana's western region. So the beach resort has farms which are basically into organic farming, but as one of the things they do, they also produce bamboo charcoal from natural stock of bamboo in the vicinity of the resort. And they also produce vinegar, the distillate from the carbonization, which they use back on the organic farm for the purpose of pest control. So this farm is using high efficiency and low emission retort kiln. I understand that is the most efficient kiln for carbonizing charcoal. but the investment requirement is much higher if you use this kind of kiln. And at the moment, the farms are only producing bamboo charcoal on pilot scale to test the kiln, but also to test the market for bamboo charcoal. The intention is to sell the bamboo charcoal within the West African sub-region as solid biofuel, but also as biochar. And the target is to produce 330 tons of bamboo charcoal every year. The farm sees very good potential for commercialization of bamboo charcoal in Ghana. And I read this quote from the commercial project manager, who said that if produced in the right way with high recovery, bamboo charcoal can be competitive with charcoal made from conventional wood and save from further deforestation. He, however, saw some challenges which we need to overcome to achieve this potential. And the first is market acceptance of bamboo charcoal being a new solid biofuel. And the second is stable supply of bamboo on sustainable basis. And the last is ability to sell bamboo charcoal at a price which makes it competitive when compared to charcoal made from conventional wood. The second case I share is that of the Global Bamboo Products Limited, which is a hybrid social enterprise, basically into the processing of bamboo into several products, which include furniture, handicraft, and they are also into bamboo cultivation. So they've planted quite substantial bamboo already. And they also do skills training. So they train the youth in bamboo and rattan processing. So as one of the things they process bamboo into charcoal and briquettes. And the pictures you see here are some of the products from Global Bamboo Products Limited, which are nicely packaged bamboo charcoal and briquettes. And you could actually find some of these products in some of our supermarkets. They see good potential for commercialization of bamboo charcoal in Ghana, but for them, these are the things that they think should happen for us to achieve this potential. So one of them is that they want us to have bamboo feedstock depots where individual small-scale producers would buy the bamboo for carbonization. In fact, one of the things this Global Bamboo Products does is that it organizes small-scale producers to produce bamboo charcoal and then buys from them for further processing into briquettes. And then they would also like the mobile kiln to be available but also affordable. So for individual small-scale producers, rooftop kiln is beyond their means, but for them, the mobile kiln is more feasible. And this can be fabricated locally. So they would like them to be available but also affordable. And then they would like to have government support in the form of policy incentives, which will create the necessary policy framework for the charcoal industry in Ghana. The last case I share is that of an individual small-scale charcoal producer, Alex Blay, in Ghana's western region. So Alex is one of the people who benefited from the INBAR project, which introduced the bamboo charcoal technology into Ghana. And since the project ended in 2013, he has been producing bamboo charcoal normally on demand, so small scale. But at the time I talked to him, he had already produced over 200 bags of bamboo charcoal, which he normally sells to a resort in the vicinity, but also to local charcoal retailers. Alex sees very good potential in the commercialization of bamboo charcoal in Ghana. But for him, as a small-scale individual producer, his biggest challenge has been low recovery. So recovery depends on many things, including the species used, the method of carbonization, even the carbonization temperature. But for him, using very local kiln, so he doesn't have the resources for a more advanced kiln, but with the kind of kiln he's using, he's facing the problem of low recovery. And he says that makes bamboo charcoal harder to produce when he compares to, he also makes charcoal from conventional wood, and he thinks bamboo charcoal is harder to produce. And it's demotivating for him that the harder to produce bamboo charcoal has to be sold at the same price as charcoal made from conventional wood. I will end with some concluding remarks. And the first remark I'm going to make is that I think Ghana has made quite significant progress in finding uses for the nation's bamboo resources. So we are using bamboo for furniture. We are using bamboo for making bicycles, but also these days we are also trying to use bamboo for the purpose of charcoal making. And on the subject of charcoal making, I think there's very good potential for upscale and commercialization of bamboo charcoal in Ghana. And this is so because over the years, the conventional wood which is used for charcoal making is getting depleted. So these days the charcoal producers have to travel longer distance and spend more effort to find the wood for charcoal making. But bamboo is available in many of these places. In fact, in some places in Ghana, it is considered a weed which has to be destroyed to make way for farming. So there's good potential to just shift from the use of this harder to obtain conventional wood to bamboo for charcoal making. But for this to happen, I think some things need to be done. And one of them is further awareness creation. INBAR has done very well. There are some other stakeholders who have done well introducing the technology into Ghana and creating some awareness. So we have some awareness already, but we need more awareness on the possibility to make charcoal from bamboo, and also all the available technology, including recommended kiln options. And then I think we need to encourage the private sector to shift from the use of conventional wood to the use of bamboo for charcoal making. And this can be achieved, for instance, through a policy incentive. For instance, if the government comes up with a new policy which bans the production of charcoal from naturally grown trees in the forest and fallow lands, then the charcoal producers will have no other option than to look for alternative and more sustainable feedstock, which would then include charcoal. And I think in Ghana, charcoal is still a very big industry. If you ever visit Ghana, you see lots of trucks every day on our major roads conveying charcoal. And if we could just switch and use charcoal for even just 50% of the charcoal we produce in Ghana every year, that will save Ghana a lot of trees every year, which we consume for charcoal making. I think I'll end here. Thank you very much.
Okay, thank you very much, Kapal, for your presentation, and it is quite informative, and it is like some good to see green shoots of the industry growing up in Ghana. And probably, as you said, the industry like your energy industry in Africa, as in Ghana, is huge. So it is like your probably like a few like $1 billion industry if we actually compare the whole of Africa into that. So now we have finished the presentation section. We have to like move into a question and answer. In the interest of time, we have around like 25 minutes for our question and answer. Probably we will be having 3 selected questions for all the speaker. So I will start with our first presenter to Xuan Tao and to Jinwai. The first question is on, can you please elaborate on the potential of like bamboo briquettes and like pellets for industrial use in Europe? Yeah, that is our first question. So the floor is free for like Jinwai or for Xuan to.
That would be for Tao to answer.
什么问题？
问题是那个就是能不能讲一下，就是说竹子竹子基质碳和这个颗粒 在欧洲的他们的这个工业化的应用前景。工业化应用前景，就是可能是在工业上的应用吧，就是欧洲市场。
I think, yeah, Mr. Chairman, I think wood pellets has a long history in Europe, but many wood pellets they imported from the USA and Canada, maybe, and Russia, Ukraine. So our bamboo pellets, but made our local. We only use the local market, but it's far away from delivered to the Europe. Far away, the cost maybe the freight cost is very high. I think if some country near the Europe, maybe they have good market, low cost for Europe. We have investigated in the SOBR 2 years ago. I think we had discussed with Chairman Julia and Dr. Fu Jinhe in SOBR. We calculate a lot. In SOBR, bamboo is small bamboo. I think we have a test. It's not good to make the charcoal. Small bamboo. Their bamboo is good to make the pulp. But now they cannot develop. But first we develop the bamboo pellets. The pellets cost is very small in the SOBR if they make the pellets. We calculate maybe we transport it to the Germany. Maybe the cost is 800 RMB per ton. 800. So the Germany, the market, their wholesale price is 1,400 RMB per ton. So the profit is 600 RMB per ton. We calculated a lot. If we developed in the SOBR. SOBR is very near to the Europe. So China is far away to the Europe. Maybe the freight cost is very high.
Okay. Yeah, I think it is clear. I think the transportation is the one which kills the profit. If like some countries like Ethiopia or the other countries which is close to Europe can produce and transport it to Europe or like USA, you have a huge market and huge some potential which can some benefit. And I would like to pose the second question to Dr. Bharati. The question is on can we use the bamboo directly for some boiler operation? Or what is the processing required on it, and what is the economy of scale required to make it profitable when it compared to coal or with other energy products available?
Yes, Dr. Dhirai. Bamboo is actually now co-fired along with the coal, and for which bamboo is chipped. It's chipped to 1 to 2 cubic inches, and then it is mixed along with the coal to a level of 5 to 10%. In fact, Government of India has given mandatory saying that 7.5% of the coal in all the factories, whether power projects or cement factory or iron ore, we must start using this to reduce the emission. In fact, Europe has gone to 20%. India is just trying to come to 7%, 7.5%. Supreme Court order. Now, this is a co-firing of the bamboo chips along with the coal, and for which the bamboo should be dried to a level of 12%. And then it should be fired along with this. Now that again depends on the boiler and the pressure of the boiler what they have. Now what normally people look at is what is the ash fusion temperature, because the ash should not get fused. Many of the biomass, they have a lower level of ash fusion. Fortunately, bamboo is able to fuse only at 1200 degrees centigrade and above. That makes it fit for the boiler to be processed. And the cost wise, 4,000 kilocalories is the energy value, the average energy value of the bamboo, while the coal is also 4,000 kilocalorie. And the price difference between the coal and the bamboo, the coal is 10% more expensive in India. We are also working with a factory in Bhutan, cement factory, where they are purchasing at 10,000 rupees a ton of coal for their cement manufacturing. This is a factory called Plantation factory, and that can replace easily with the bamboo chip, or you can also go to the next level of converting bamboo into charcoal, and the charcoal could be replaced, whereby the energy density of the coal increases. 4,000 kilocalories is the energy of for bamboo, and 5,000 kilocalories a carbonized bamboo per kilogram, whereas the charcoal goes anywhere from 6,000 to 7,000 kilocalories. And there are processes by which we can increase to 8,000 also, but then this is it's a high power coal which is possible to produce, and all everything is getting explored now. And simple today is what's happening is it's being blended. For example, Dalmia Cements in Assam and Meghalaya, the factories are mixing with three numbers, mixing 3% of the material they started. Now they have reached a 10% level. They have reached. Now the same thing is happening for a sugar mill. For example, Maharashtra, there is a mill called D.Y. Patel Satkari in Kolhapur. They have started growing the bamboo along with the farmers as a contract farming. They are collecting the bamboo and they are burning 100% of the bamboo, 100% during the off season. And this kind of a contract farming also coming up. Bamboo is replacing at a very cost effectively the coal.
Okay, sir. Okay, great.
Thank you.
And then the next question is for like Mr. Jaya. The question is on like what is the mechanism? Yeah, I think like what is the mechanism you guys have like some put in place to pay the cost for the farmer, and also to collect the revenue from the farmer by sale of electricity, and like what is the cost the farmer could be able to get by the sale of like your dried bamboo chips? Yeah.
Okay. All right. Very clear. The scheme that we built for the community in Mentawai, and then the next community in Nusa Tenggara, which is in eastern part of Indonesia, we help the local to have concession of land. Okay, so they will have a land tenure of the land to plant the bamboo for 35 years. And the condition that the government gave to the local community, they have to supply the bamboo to the power plant, to the local power plant. So the contract is a prerequisite before they can get the land tenure. So they cannot plant other types of biomass in that location because government helped them to have the seedlings, and they pay them to plant the bamboo. So in this case, the government is giving it's paying forward. So they give the money now, so they have the bamboo and the land to generate income for years to come. So it's like they're saving. And the payment that we give to the local, to each household that that become our biomass producer is not for their only income. It's for supplemental income. So basically to give money to them so they can pay for electricity. The payment is around 300 rupiah per kilogram, which is around $20 per ton. Okay, $20 per ton. There is no cost to bring that to the power plant, because we pay the local village entity to do that. So the household just plant the bamboo and cut the bamboo and then leave it in the roadside. The local village entity bring that to the power plant. The power plant convert the bamboo into electricity and sell it to PLN for 15 cents per kilowatt hour. So it's quite high tariff. Why PLN want to pay for that much? Because if they don't buy from us, they will have to burn diesel, which is going to go up like a 30 cents per kilowatt hour. So by switching from diesel to the biomass, they cut a cost by half. But because this is subsidized tariff, the PLN has to sell for 3 cents. This is applied to whole population of Indonesia, where they have a low income. So in that case, government help the local community with the planting, and government help the community by subsidized tariff. So that's why we are going. The idea is not only supplying electricity, but also to help them to have buying power in the years to come. In the future, what we hope that gonna happen is that when the community industrialize, so they will have more money, not only by selling the bamboo, but also by using the electricity for more productive use, not only for lighting, but also for woodworking, for cold storage, for fish product processing, for sugar processing, other types of farming product processing, then they will increase the use of electricity. The PLN doesn't need to subsidize anymore, because if they switch from low income user to higher income user or industrial electricity user, then they pay non-subsidized tariff. So this is the way that we bring the community from least developed to developing community to well-off community. Thank you.
Yeah, I think the answer is like very clear, and yeah, I think the next question is to Dr. Paul. So how do you compare the bamboo charcoal with acacia? Because in Africa and in like most of the South Asian countries too, they use acacia for the charcoal production. In terms of its economics and also the social acceptability, the acceptability and the economics, how do you compare the bamboo charcoal with acacias? Yeah, so as was the question, yeah.
All right, thank you very much, Durai. So economics wise, I think bamboo even has comparative advantage. And the reason I say this is because unlike acacia, which we have to plant new, acacia doesn't grow naturally in Ghana. So if you want to have an acacia stand, you have to plant. We have a lot of bamboo, which unfortunately is not managed. So like one of the earlier speakers said, when it's not managed, it's not very good for industrial use. So let's have bamboo that we cannot use for any serious industrial use, but it can be used for the purpose of biomass energy. So in terms of economics, if you want to produce charcoal or for the purpose of biomass energy, it makes more economic sense to use the already growing bamboo than to start a new plantation of acacia. However, the problem we have is with social acceptance. I don't know how come we came to accept acacia. I see a lot of acacia plantations in Ghana now, but a lot of people have not come to accept that you could actually use bamboo for the purpose of biomass energy. So that is where the challenge lies, to create more awareness. And a lot of people are surprised when they see that you can make charcoal from bamboo, even from, we have the Bambusa vulgaris, which is large with a big hole. But even those ones, if you have the right technology, you could actually convert into charcoal. And it makes a lot of, in fact, if you establish an acacia plantation and a bamboo plantation, the bamboo is the first to be ready to harvest. So it has a lot of comparative advantages of acacia. And we just have to create more awareness and gradually have the shift to the use of bamboo. Thank you.
Okay, great, Paul. Yeah, thank you very much. And then we can go to our second round of like some questioning. I would like to put the first the question to Juan Tao. The question is there small scale like some machineries available for briquetting and like some pelleting from your experience, like what is the lowest scale like some possible for an enterprise to be economically feasible?
涛涛，这个问题你听清了吗？他就是说这个做这个颗粒的工厂，最小规模是什么样的规模？然后呢，最低的这个投入应该是多少？这样子。
Okay. Chairman, Mr. Chairman Duli. So I think maybe it is very simple. Now, yeah. So I introduce our bamboo machines. Our pellets machine made in Jiangsu province in China. This company very special. The first they joined the venture with USA. USA's pellets machine factory. But the USA, they cannot sell their machines in China. But China maybe no wood to make the pellets. So the USA, they don't join the venture with China. In China, only this machine. We have tested many machines in China. Only this company machine could be used. We select the type. This machine, we could produce 2 tons per hour. 2 tons. You can calculate the pellets water content is 10%. So if we know the material water, we calculate the material, how much the material. So the one machine, maybe we should prepare 2 machines, two machine pellet machines too. Maybe one work, maybe one machine cannot work. We should prepare. So one factory, the minimum should prepare 2 pellet machines. Our pellet machines is 2 tons per hour, but now we have tested 5 tons per hour the machines. But these machines is too big, cost is very high. So pellet machines join together. Another the control machine and join together. The price is 1.5 billion per pellet machine made in Jiangsu province. Another equipment is dry machine and deliver machine and the powder machine. And yeah, maybe to set up a factory, maybe 300万那个500万 maybe you should pay a machines cost 5 million RMB. 5 million. Yeah. So material I don't know the water content. So two machine, one machine work 20 hours. 20 hours, 2 shifts. In China, 2 shifts. After 20 hours, we should check the machine, should stop. So our capacity one day is 80 tons one day, and working 300 days a year. Maybe holiday, maybe Sunday. Maybe we should check the machine, change the parts. Working 300 days, so we calculated the profit and the material prepare. Yeah, okay.
Yeah. I think it is clear. The important like some messages. So it is like a business of economy of scale. So if you want to be profitable, you be at least having 2 tons of production per day, and have a spare like some machine along with the production line, like because in screw type production you have to sharpen and like I weld the screws after like some period of operation. So that is why the answer. So, and then the second question is to Dr. Bharati. The question is like very pointed, and it says like what is the fertigation as well as like some irrigation like requirements of your Bima bamboo to obtain like 40 tons of like some biomass like per acre per year.
Yes, Doctor. The bamboo requirement is around 2000 millimeter water to give the 40 tons per acre, which in other words, it's 20 liter per plant per year. And that water is it's able to, if you're able to provide through drip irrigation, so effectively water is used. And normally there is a rainfall of 700 to 1000 millimeter rainfall would be there. So detecting that, the rest of the water should be irrigated throughout the year. If there is a rainfall is continuous, no problem at all. Otherwise, we need to irrigate it. So in terms of it is 2000 millimeter. In terms of liter, it is 20,000 liter per acre per day. Now, coming back to fertigation, yes, when a bamboo is growing at the speed of 1.5 foot at a time, and then it is able to produce 40 tons, 1.6% of the biomass is a nutrient from the soil. That is nitrogen, potash, and phosphorus. So 0.6% is a nitrogen, 0.8% is the potash, and 0.1% is the phosphorus. This is what is getting depleted every year when the bamboo is growing. So when you convert them into fertilizer, it comes to 160 kg of nitrogen, 40 kg of phosphorus, 200 kg of potash per acre per year. Now, all that should not be given on the day one itself. It should be split into 50 dosage or a 40 dosage to give over every week. Because when you supply all the fertilizer together in one shot, something is getting fixed in the soil, something getting absorbed, something getting evaporated, something getting leached. Now, that's the reason fertigation, a process by which the nutrient is given through the water, irrigation water, dissolved, slowly it is given, and it is given every week. And that quantum of fertilizer is changing right from the first year, second year, third year. It's first year it is going to be only 40% requirement. The second year is going to be around 80% requirement. Third year, when the growth is full, they take 100%. All these calculated based on the existing soil. The soil has got some amount of nitrogen, potassium, phosphorus, and that is detected. So for which the soil is tested, not normal agriculture practice. Normal agriculture practice, we test the soil only just in the top 6 inches. Bamboo root goes to 2 feet, and they take all the nutrient in the 2 feet. We cannot just work only with the 6 inches. Now then, for that reason, the soil test for bamboo is different, where the soil is tested in the top and again the bottom 2 feet. Those two soil is taken, and we have a system to calculate what is the amount of nutrient available in the soil for the bamboo, and the balance is worked out. What I said is 160, 40, 200 kg of NPK is a blanket requirement. Depending on what is available is going to be detected. Now, there comes again the microorganisms to fix the nitrogen. And if the nitrogen organisms activity is better and the soil pH is ideal, then further nitrogen is going to come down. We also use nitrogen, phosphorus solubilizing bacteria, potash solubilizing bacteria. All these are given along with the plant in the poly bag itself to the farmer. Farmer doesn't understand all this. We just put the inoculum, give it to them as a bag. He takes the soil, he plants it. At that time, by itself it goes, they start breeding it. So it's a 3-4 combination of one existing soil, another what microbes is going to do. The balance is going to be provided through the fertigation. So irrigation schedule, it depends on the water. If the water, normally bamboo needs 5.5 millimeter every day. That's the rate of evaporation under normal condition. If it's a day with the temperature of 40 degrees and the humidity of 20%, naturally the water loss is going to be more than 10 millimeter per day and loss. So accordingly, the water is irrigated so that the leaf doesn't roll. What happens when the stress is there, the bamboo leaves start rolling. Once the rolling takes place, the photosynthesis comes down and they are not able to effectively collect the photons and then do a photosynthesis. Ultimately, the yield is going to get affected. So when you optimize all these, the yield can go not 40 tons, it can go to 60, 70 tons per acre per year. And depending on the place, depending on the soil, one has to recommend the water requirement and the fertilizer requirement. We assist all the people whenever the project is done. We take the information on the soil fertility, water condition, the climatic condition, the rainfall, the sunshine hours, including this the wind velocity, and then we calculate what is the yield possible and what is the amount of nutrient to be given to them. This is a simple mathematics. It's more of agriculture, which is lacking in bamboo cultivation. It is there in banana. It is there in sugarcane. So.
Yeah.
Do I turn on your microphone?
Yeah, I'm sorry. Yeah, always I'm saying the input is equal to output. So it is always a balancing act, like whether the smallholder farmers or like whether the farmers in different contexts can apply his. And of course, if the bottom line is if we provide fertigation, if we provide like some irrigation to bamboo, it shows amazing like results. So we want to like thank you for clarifying that. And the next question is for Jaya. Again, the question is, what is the species of like some bamboo you specifically use, and what are all the pre-processing like requirements or steps you undertake before the bamboo chips is like fed into the gasifier unit?
Okay, so we use 3 species, Dendrocalamus asper. We call it petung in Indonesia. It's a native species in Mentawai and all over Indonesia. It's very common. And then Bambusa balcoa and Bambusa vulgaris. So those are the 3 species that we use, and we got the seedlings from Bambu Nusa Verde. It's a local Indonesian tissue culture producer in Yogyakarta, which is in Central Java. They've been exporting seedlings to Mali, to Brazil as well. And now we are working together to promote bamboo planting for land restoration and energy production to the government. So government of Indonesia is focusing on 3 things right now that help this scheme to work so well. One is that the government want to achieve 100% electrification ratio by 2021. I think the target last year is 2020, but because of the COVID, they delayed the target to 2021. When you bring 100% electrification ratio to all the people in Indonesia, in small islands, big islands, then it's very tough not to switch to local renewable energy. Because if you're relying on diesel gensets, not only that, it's going to be unreliable, because sometimes the diesel fuel can be late to arrive in the community, but also it's going to be very expensive. Even when the crude oil is low, price is low, because there's cost for storage, cost for transportation, for security, and so on and so forth. So switching to local renewable energy sources is the way to go. Number two, the government want to restore the land, the non-productive land, and bring forward the local food production. And by having local energy source, then the community can process. So the food waste is huge problem. Not only Indonesia, but also in many developing countries. So by having the local source of energy, the community can process the food, reduce the food waste, and having higher value of their farm products. Number three, the government also wants to reduce poverty, create jobs, especially during the pandemic. I think it's true for all over the world, especially in developing countries. We cannot rely on central government all the time. We cannot rely on development agencies all the time. We cannot rely on big corporations to come into the community. We have to help the community to help themselves. This is the way for the community help themselves, because then they can produce energy, they can produce food, they create jobs, jobs that cannot be replaced because it's 100% local. They have the concession of land, they own the bamboo, and they consume the electricity. So that's the idea. For replication.
Yeah, thank you, Chaya, for the answer. And I think we are already like over the time. So I think the final question would be for Dr. Paul. And after that, we can formally close the session. And if there is any unanswered questions, our colleagues will compile and then send it to you, and then you can choose the questions from the participants, and then like we can answer the question afterwards. So Dr. Paul, you will be having the opportunity to have the final question. So a participant have asked, have you guys, in addition to the use of like some bamboo for charcoal and for energy, have you tried promoting the bamboo biochar for soil conditioning and to improve the soil parameters in terms of its carbons and in terms of the climate change and other aspects? If you have any experiences, please share with us.
Yeah, thank you very much, Durai. I think the use of charcoal as soil conditioner is quite new in Ghana. Northern Ghana is drier than Southern Ghana. So in Southern Ghana, in fact, I'm yet to come across people using charcoal as a soil conditioner. But in the northern part of Ghana, I have seen that. In fact, I have a friend who is in Northern Ghana working with farmers, and that's one of the things they are promoting in Northern Ghana, using charcoal to make the soil better for farming. So it's still new, but I know it has started in the northern part of Ghana. And let me quickly answer a question from one of the participants. He was asking the kind of kiln the small scale charcoal producers use in Ghana. And I'll say they use basically two. So we have the metal kiln, which can be made locally. So just the sizes can differ, but it's made from metal and with a cover. And then some of them are using, it's like, it's not a brick kiln. The brick kiln is much more expensive to make, but they can make a mount. It's locally made. So they also use a kind of kiln which is made from the earth. And those ones are very cheap. He was asking about cost. Those ones with a few, maybe $100, you could make that. But a metal kiln, you need maybe $500 to $1,000 to make a metal kiln. All right, thank you.
Okay, thank you, Paul, for that. And since in the interest of time, still we have like some further questions to answer. So since in the interest of time, like we couldn't able to take up all the questions, probably we will find a mechanism to answer the questions and then make it available to the participants. So to close, I want to thank Sean Otto and Jinwai, Dr. Bharati, Jaya and Paul for their excellent presentation and their effort to participate in the session as well. I think today's session was quite informative, and then it is quite good, and I hope should have also like some benefited all our participants. I can also understand it from the questions like which is being asked by the participant, like which is quite mature. And we have like plenty of like some questions as well. So I would also like to thank Jinwai and Xinghai Yu, who is my colleagues, who has been in our background. I want to thank all of you. And, have like some good afternoon or like some good evening or like some good night as per our zones. And if we have another session like some coming up probably on next Tuesday and also next like Thursday. So if like some Jinwai wants to make announcement about the upcoming sessions, the floor is yours, Jinwai.
Hello. To introduce next session, coming sessions.
Yes.
Yes. Yes. Next Tuesday, we are going to have a session about the bamboo supply. How to say the proper bamboo development models for different regions or different countries, and we're going to introduce several cases in some countries. And then next Friday, we are going to have a session especially focusing on the mountainous development. And mountainous development is a very special topic and also a hot topic because in the international society, the mountainous development has been a very focused topic ever since 1970s, and the UN has established our special organization and also have a special convention regarding to mountainous development, which is managed now by FAO. And it's quite related with natural resources management and also biodiversity conservation, as well as the people in the dwellers in the mountain and forest. And we know that bamboo and rattan, most of the resources located on the slope, in the mountainous area, and they were they were very easy to access by the local people, and they are probably the most profitable and renewable biomass materials they could get. We also know that they play very important role in the biodiversity. So this is important topic we are going to discuss, how to make ecology and economy balanced in the mountainous area, and how to develop a green sector. And this could be very important topic, because mountains could be the source of freshwater resources, could be the source of mining resources. So conservation of the mountainous area is very important. So thank you. You mute your microphone again, Dorai.
I want to thank all of you again for participating, and we would have liking to see you again in some of our webinar sessions soon. So I thank you very much, and then have a good day, or
Thank you. Bye bye.
Okay.
Thank you, Dorai. Thank you, friends.
Thank you.
Thank you, everybody. Bye.